Good morning, guys. Sorry I'm not here today, but with the weather and the lack of fields for both teams, we had to make some last minute adjustments, and I am out when I was planning on being here. But you still get virtual, Mr. Coach, so here we go. Today we're talking about writing equations of lines. Unit 8 is about modeling and coordinate plane geometry. So, of course, we've got to talk about parallel and perpendicular lines. But before we can go too far into those, I want to remind us about writing equations of lines that we learned way back in Algebra 1. Okay? So we can see up here at the top, writing equations of lines, y equals mx plus b, which is, of course, our slope-intercept form. Okay? So y equals mx plus b is called slope-intercept form. And we call it slope-intercept form because it shows us a slope and an intercept. So if I look at my equation, m, maybe if my pen will write for me, m is my slope, and that's just my change of y over my change of x. And then b is my y-intercept. Okay, and hopefully, again, this is a little refresher. This is from way back in the Algebra 1 days. We'll turn that off because we don't like that. Okay, and first off, we want to write an equation, and we're given the slope and we're given the y-intercept. So we're going to take our equations, plug them in, and then simplify. So I look at number 1. Slope is -5, and the y-intercept is 2. So remember, slope is our m, so m equals -5. And y-intercept is b, so b equals 2. That was a funky shape. And it disappears. Apparently the 2 doesn't want to happen today, guys. Sorry about that. Okay, so we've got our equation, slope-intercept form, y equals mx plus b. Okay, we're going to plug in -5 for m. So y equals -5x. And then 2 for b plus 2. Right, and then that is our answer. That is in slope-intercept form. Okay, let's jump down here to number 3. The slope is 0. Okay, so m equals 0. It's a little funky. And our y-intercept is 3. So b equals 3. I want to take my equation, y equals mx plus b. I'm sorry about this iPad, guys. It is not cooperating a whole lot. And we're going to plug in what we know. We know m is 0, so 0x plus, not b, but 3. So 0 times x, anything times 0 is 0, so that guy's just going to disappear. So we get y equals 3, which we know is a horizontal line where the only value that will ever occur for y is 3. Now let's take a peek. Let's find the equation when I'm given a graph. Okay, there's a couple of ways we can do it. We can do finding slope. And the equation for slope, if we think back to Unit 4, we saw the equation for slope. So y2 minus y1 over x2 minus x1, where we can find two good points, okay? Find two good points and then find slope. Or we can count the slope. It's up to you. It's whatever's easiest for you. So the first thing we want to identify when we're looking at our graph is where does my line intersect the y-axis? Because that is going to be my value of b. So when I look at number 5, where does this blue line right here, where does this blue line intersect the y-axis, which is our vertical axis? And if I look really close, I can't write in highlighter, can you? If I look really close, right there, that's where my b occurs. So the value of b for this one is positive 2, because that's where it intersects. Slope Again, I can pick 2 good points. When it says good points, it means I want 2 points that I for sure know are values. I don't want to pick, so what I don't want to do, whoa, can't go to that. What I don't want to do is I don't want to pick this random point right here because then I got to guesstimate. I want points where my line is perfectly on the other line. So if I look closely, there's not a lot on this graph, so I'm going to write this one in blue. Okay, but I've got this value right here. Okay, that point is perfectly touching 2 corners, and then I go way up here and I can find this point. A little trick of the trade, I could also use my y-intercept if I really want to. And it's probably recommended because that would make x 0, and that's okay. So I've got 3 points to choose from. I've got -5, -2. Okay, so -5, -2. Okay, that's 1 point. I've got 0, +2, and I also have, what is that? 5, 6. So I've got 3 solid points that I can go ahead and try to use. Okay, so remember we're going x1, y1. I'm going to stick with these 2 at the top. I'm going to go 0, 2, and 5, 6. So y2 minus y1. Ooh, can't do that, can you? So y2 is 6. X2 is 5. Come on. Write for me, big guy. There it is. And then x1 is going to be 0, if my pen will cooperate. And y1 will be 2. Okay. So here we go. We're going 6 minus 2 over 5 minus 0. Come on. There it is. Okay, 6 minus 2 is 4. And 5 minus 0 is 5. Now, we can check our work. We can check our work by counting. Okay? Count and slope. So, do I go 1, 2, 3, 4? Whoops. Let's go, yeah, so we're going to count. So, up 1, 2, 3, 4. Up 1, check. Right 5. Let's see. 1, 2, 2, 3, 4, 5. Look at that. So our slope is indeed 4, 5. So now we know our slope. We know our y-intercept. So let's go ahead and plug it in to y equals mx plus b. So we know y equals, man, this stylus is jacking it up today. Y equals 4/5 x plus 2. That is the equation of our line. Our slope was 4/5 and our y-intercept was 2. Let's do one more of those, but this time we're going to have a negative slope. So, number 12 looks fun. It's in red. Red's a good color. Big fan of red. Go dogs. Here we go. Let's identify our y-intercept. Where does this red line, if I'm looking at my red line, where does it intersect my vertical y-axis? And I look, there it is. There's my B. Okay, there's my B. Come on, thingy. All right, so I know my y-intercept, my B, is 3. All right, so let's look at the other part. Let's find one more good point that we know on this graph. And if I'm looking, because I need to find my slope, remember that's y2 minus y1 over x2 minus x1. Okay, and if I look real close, again, we want ones that it comes together perfectly in it. So we don't want to use this guy. He's in the middle. He's floating out there. We got to guesstimate. We don't like to guesstimate. I want to be exact. So if I look really close, right here, okay, I've got this value, which is 2, 0, and then I have my y-intercept, which was 0, 3. So there's my 2 good points. So y2, x2, x1, y1. And I know what you're thinking. You're like, Coach, how do we know which one's x1, y1, which one's x2, y2? Generally speaking, we read from left to right. So if I'm looking at my graph, I go from my left, which is my negative x infinity, all the way to my right, which is my positive x infinity. Okay, so left to right, x1 to x2, y1 to y2. It even was consistent up here. Our y-intercept value was our x1. Our next point was our x2. So you read left to right. Okay, we plug in our numbers that we found because we're rock stars, and that's what we do. All right, so it equals So y2 is 0 minus 3 over, well, I put that way up there, didn't I? 2 minus 0. And of course, my slope is negative 3 halves. Okay? This is a negative slope because our line is sloping down. Again, we read left to right, which means if I drew a little ant right here, okay, my little ant, fancy little feller, he would, instead of climbing up a positive slope, he slides down on a negative slope. So the equation of my line is, here we go, y equals my slope, which is negative 3 halves, x, plus my y-intercept, which is 3. And I'm going to post another video, guys, that would help us with our lines, just in case we need some extra practice. But let's go to the next page. All right. Now, this is new. This is something different. I don't know if you guys have ever used it before. Okay. I'm going to show you a different way rather than plugging it into mx plus b and solving for b. I'm going to show you an equation. Okay. And that equation is called point slope. Okay, it's a new fancy equation. I'm a big fan of it because it allows you to take the value you have, which is our slope and our point, and plug it right in. And instead of having to solve for b and then turn around and plug it back in, you're just going to be able to solve into slope intercept form and be done. Okay, and that equation is y minus y1, which is our point value, equals m times x minus x1. Okay, so if I look at my equation, I've got y minus y1 and m times x minus x1. So our order of operations is going to be important here. So this is a y value of our point. Okay, m, of course, is still going to be our slope. Okay, that's still going to be our slope. M doesn't change. Apparently my ringer just turned on. And then x1 is the x value. Okay, y and x are going to continue to be our unknown constants. However, when we plug these guys in, it's going to pop it right in for me. So order of operations is important here. But this little point slope form will help make us a difference. And if you don't want to do this and you want to be like, Coach, it's just really not clicking for me, you can use the y equals mx plus b, plug in y and x as your values of the point they give us, and then solve for b and turn around and shove that back into the equation. This will do the same thing as that. It's up to you. Okay, so if I look, it says my slope is 2 and my point is 2, 3. So I've got my x1 value and I've got my y1 value. So when I look at my point slope form, okay, so remember it's y minus y1 equals m x minus x1. Okay, so we're going to plug in what we know. I'm going to plug in what we know in a different color. I know my y1 value is 3. My slope is 2. And my x1 value is positive 2. So we took what we know and we plug it in and help us solve. Okay, so now we're just going to solve for y. We want to isolate y, get y by itself. So I've got y minus 3 equals 2 times x minus 2. We just cleaned up the equation, got rid of those extra parentheses. If we had to use a negative there, if this was like a double negative, we would have made a positive, but it wasn't, so we're going to be there. All right. So the first step we want to do, of course, is we want to distribute this 2 into both values. So we can follow along, tra-la-la, right up here. Okay. So I get y minus 3 equals 2x minus 4. Because 2 times x is 2x, 2 times negative 2 is negative 4. One more simple step and we're finished. Because we're trying to isolate this y, we're going to add 3 to both sides. Take that. I'm a wizard for that straight line. 3's cancel on the left, leaving me y equals 2x minus 1. And that's the equation of my line. All right, let's do it one more time. Okay, look at number 15. So again, point slope form, y minus y1 equals m times x minus x1. Okay, I've got my x1 value, my y1 value, and then I have my slope. So here we go. Look at that little negative I was talking about. Again, I'm going to write my input values in red. So y minus 3 equals our slope, which is negative 2, times x minus negative 5. Okay. So like I said, every now and then we've got to clean that rascal up a little bit. So I've got y minus 3 equals negative 2 times x plus, because a double negative makes a positive, but two wrongs never make a right. So I'm going to distribute my negative 2 into both values, okay, because I'm going to follow my order of operations. So y minus 3 equals negative 2x minus 10, because a negative 2 times a positive 5 gives us a minus, a negative. Okay, we're going to carry that rascal up there again. All right, one more easy step, and we're going to add 3 to both sides. So y equals negative 2x. Negative 10 plus 3 makes minus 7. There's the equation on my line. Okay, that's using point slope form. Okay, let's do one of these where they give us two points, and we're going to first find the slope using m is y2 over y2 minus y1. So we're going to label these guys. Nope, x comes first in the coordinate plane. x1, y1, x2, y2. Come on, stylus. Okay. So we're going m equals 5 minus 3. Let's write this equation out so you can see it. y2, m equals y2 minus y1 over x2 minus x1, which equals, okay, so we're going to take our values now. 5 minus 3 over 4 minus 2. Uh-oh, thank you, math. How awesome are you? We get 2 over 2, which the slope is 1. This is a good example. Now, we are going to take either point we want, and we're going to use that to do our point slope form. Remember, it's called point slope form because we have a point and we have a slope. Again, you can plug it into y equals mx plus b if you want to, but this way gets you exactly what you want, exactly when you need it. So y minus, I'm going to use the first one because it says x1, y1. Y minus 3, come on parentheses, come on 3, equals our slope, which we just found to be 1, times x minus 2. Clean up our parentheses, see if we got to apply any negatives, but we don't. Come on, pen, don't fail me now. You're doing a great job. Y minus 3 is x minus 2. So because our slope was 1, we don't write that 1 in front of the x, so we just drop them off of there. I'm going to add 3 to both sides. Okay. Which cancels the 3 on the left and gives us y equals, that's a cool y, x plus 1. Guys, I'm going to post some more videos that can help you substantiate what we did, but this is your lesson for the day. Thank you so much for your patience and understanding. And if you want to, you can go back and watch this over and over again because I know how much you love hearing me talk. You guys have a great day, and I will see you tomorrow.